All right, everybody, and welcome to the most recent live YouTube weather and climate office hours with your host Daniel Swain. By the way, I am working on a new intro video for the channel. Probably nobody who's already on this is particularly interested in another intro video, but I do think it's important in building an audience, and thanks to some support of folks, I should be able to do that soon. So you can check out the glitzy new intro video at some point in the next month or so. I'll let you know when it's there. Anyway, welcome everybody, and I'm glad to say that I've been able to space out the sessions a little bit more over the past week or so because the weather has calmed down in California, giving me a little bit of a chance to pick up the slack elsewhere in my role. Been actually able to create a couple of figures and do some writing. Need to do a lot more of that than I have been recently, but the weather is going to take another turn for the more active in California again this weekend. I'll be talking about that primarily today, but I don't think the impacts will be quite as significant as with the last round of storms, although they could still be substantial. So probably won't be showing up twice a day live during the event, but there's still a little bit of uncertainty, as I'll get into in a moment, so we'll just have to see about that. So I do think there'll be a little bit of time at the end of the conversation today to discuss a few things beyond California weather. One thing I did want to touch on was the recent media hubbub and social media. Well, there were some not quite so accurate headlines out there in the popular press and on social media about the Atlantic Meridional Overturning Circulation, or the AMOC by its more commonly known acronym. And there are some rumblings for real in the scientific community there, so I thought it would be interesting to discuss the complexity and the nuance in that situation as well, partially as an example of a situation where there is genuine disagreement among scientists and genuine uncertainty as to exactly what's going on, but in a manner that is actually quite consequential for what the global climate will look like over the next century or so. So I thought that would be, it's a big topic. I'm not going to cover it comprehensively, but I did think it was worth a little bit of a conversation toward the end of this live office hour after talking about the upcoming active weather in California. So as I mentioned, of course, it did finally dry out in most of California. It hasn't been completely dry for the past week. There has been some rain, but generally speaking, no big storms, no flooding, no big windstorms and power outages. Quite different from 7 to 10 days ago when all of those things were happening across much of California. And there is, as had been widely predicted, a couple weeks in advance, so this is a pretty good, excuse me, I'm trying to fight a sneeze. I fought it unsuccessfully. Just as had been predicted really a couple weeks ago, so this is another successful subseasonal prediction this year. The active period with yet another low-latitude Pacific jet extension is once again occurring. That was something that the model ensembles had suggested was highly likely to happen right around now, mid-February, and it is happening right on schedule, so thumbs up for that subseasonal prediction anyway. And then it looks like there's going to be a moderately long period of some increasingly active conditions across California before things perhaps they may calm down again slightly as we go towards the end of February. So I think what I'd like to do first is pull up the model data, go through some satellite imagery, show some stuff on screen. So what you're going to see on your monitor is all of that, or on your smartphone or whatever device you're using these days. Actually, I don't know. I haven't checked to see what the device split is among people these days. Anyway, you'll see some imagery. My face will go away, and then it will come back again later during the more intensive discussion. So let me share my screen here. Just got to share the right windows. Okay, and here we go. So actually what you're seeing right now is not what I wanted to show you first, but I will go back to that in a moment. So here first is the satellite imagery. And what you're seeing right now is a broad view of the northeastern Pacific Ocean. Of course, you can see California and the western US in this view, and what we can see is a few things of interest. One, if you look over the land, is right now it's a bit of a calm period across the land area in the western US. There's no major storms. You can actually see the ground surface in many places, and you can see in some cases the snowpack or lack thereof. And look up in British Columbia, and in particular the southern part of BC, north and east of Vancouver. There is snow on the ground, but most of what you see is up in the higher mountains. There is not a whole lot of snow at lower elevations, and what you see there is a very thin snowpack. So southern BC is experiencing a severe snow drought right now. It's been fairly wet in terms of rain, but it's been a warm rain, and in between it's been rather sunny. So up there right now, there are growing concerns about a snow drought and then turning into an actual drought this coming summer, particularly if the remaining subseasonal prediction of a drier than average remainder of the winter and a much warmer than average winter and spring continue to be the case up there. You can just barely see in between some of the breaks in the clouds the Sierra snowpack, which is doing okay but not great. In fact, I don't actually have the numbers in front of me right now, but I believe we're hovering between about 65 and 75% of average in terms of snow water equivalent, depending on where you are, which again is not a terrible number, but it's also not a great number. And there are certain parts of the mountains where that number is actually a lot worse than the statewide average, in particular at lower elevations. 4, 5, 6,000 feet, there really is not a good snowpack at all right now. A lot of that snow water equivalent is contained in the upper elevations. Very much a sort of warm year climate change kind of signature that we increasingly see, as the snow water that we do see accumulate is largely coming from the upper elevations more so than the lower elevations. Again, last year was a big exception to that, but this year is certainly a return to the long-term trend in that sense. Again, it has not been one of the more terrible snow years on record in most places, but it's certainly not a good one. And right now, with this upcoming storm sequence, unfortunately, as I'll mention in a moment, these are not extremely warm storms, but they're also definitely not cold storms. And I have a feeling that this is going to be yet another sequence of events where models are somewhat over-predicting the amount of snow that's going to fall. Not necessarily the amount of precipitation, so I do think it'll fall, it'll get wet out there, but I think snow levels are going to be higher because there's no real cold air source for the Saturday and Sunday big storms. And really what we've seen this year and in recent years is unless there is a really clearly defined cold air source that's in place either before the storm hits or while it's hitting, that cold air coming in the backside really hasn't been enough to generate those lower elevation snowfalls. So I think that this already the snow level looks like it's going to be 6,000 to 7,000 feet or even higher for most of the storm. I wouldn't be too surprised if it was even a little bit higher than that. So again, this is probably going to be another disappointing system for those at Lake Tahoe level and below in terms of elevation. Again, top of the ski slope chairlifts are going to do differently. But again, that's relatively rarefied air in California. So, and part of the reason for this is somewhat intuitive just by looking at the satellite imagery. Again, you can see, here is Kauai, so this is the northern edge of the Hawaiian Islands. You can see that this first system, which is due in later today into tomorrow, which is off the coast now, it's not super strong. There are neither very heavy rains nor very strong winds associated with this, but it'll be a decent hit of some rain and some breezy winds up in central and northern California. This is storm number 1 this weekend, the weaker of the two. It does have a subtropical connection. There is some moisture streaming back to near Hawaii. Again, it's not extremely strong, sort of qualifies maybe as a marginal Pineapple Express type system, but the first storm in the sequence doesn't really have the oomph needed to squeeze out all of that moisture preferentially, which probably also means that snow levels won't get down too low because the intensity of precipitation is not quite enough to drag that colder air down from above. So especially with this first storm, I would expect snow levels to be pretty unimpressive. There could be some decent rain, even up at lake level, but relatively warm and not super intense storm. But that's storm number 1. Storm number 2, due in on Sunday into Monday, does look significantly stronger, and there is a wider range of possibilities associated with it, including the potential for some more significant wind and certainly more widespread and heavier rainfall. That could lead to some flooding, although probably in different places than what the last storm sequence. So the good news, bad news is, the bad news is, some new places that didn't see flooding last time could see it this time, but the good news is it probably won't be super severe because we are spreading it out, and it isn't just hitting the same area that got hit last time. Again, there will be, of course, some rain, heavy at times in Southern California and certain parts of the Central Coast, particularly the western part of the transverse ranges, so from Santa Barbara County westward, could see at least conditionally significant flood risk, depending on how this evolves. But this does not look like a huge rain event in the same way for, say, Los Angeles as the last one was. Could see a solid couple inches of rain, which is certainly nothing to sneeze at, especially in a year that's already been quite wet in LA. But compare that to parts of the city that saw 8 to 12 inches in 2 days during the last round, and you can see that it is not going to result in as many problems. On the one hand, the saturated antecedent soils down south kick this storm up a notch in terms of potential impacts because, of course, if everything is already wet, it takes that much less water to cause flood and mudslide and debris flow problems. But you then probably take it down 2 notches because it probably won't be as intense or as persistent, at least from Los Angeles County south and east. So probably a lower impact storm from LA County south and east, but a higher impact storm, at least in terms of rain, for Northern California, because the heaviest rain with this one does appear that it's going to be aimed more at the northern 2/3 of the state. Maybe I guess we can call it the upper Central Coast, without getting into the politics. The geopolitics of which sections of the California coast are truly the Central Coast, probably talking from about Santa Barbara County northward as being the main rain-related impacts from this storm, although there will be some heavy rain to the south and east of that, and I'll show that in a moment here. So let me pull up some model data. I just want to show the potential sequence of storms here. And here you may notice that I'm choosing I'm going to zoom out a little bit, the American model, the GFS, not because it is necessarily a better model, but just because in this case the difference between the European and the American models are not super huge. This system is only a few days out. And it gives you a good sense of what's going on. So I've zoomed out to the North American view. You can see this first modest system coming in, mainly starting Saturday morning and through the day. Really, this is a Saturday storm. And there'll be some light rain, as I mentioned, about as far south as Santa Barbara County, with some heavier rain potentially up along the north coast and in Northern California, but nothing extraordinary. This is a very ordinary, maybe even underwhelming winter type storm Saturday, but it will get things wet. It will elevate those base flows and those creeks and streams, bring some high elevation snow anyway, and will also prime the ground to be moist and saturated prior to the stronger storm coming in on Sunday, which is the one that's more likely to cause some problems. And this is that Sunday storm. You can see it forming off the coast and strengthening a bit before, strengthening first offshore, deepening to about a low at 983 or so millibar low, but importantly, this is doing so a good 500 to 800 miles west of where the big storm that caused the severe wind damage in Northern California 10 days ago did so. So although it may get down to a similar level of low pressure, it's not going to be as compact a system, so that pressure gradient will be spread out over a wider area. And it's going to be doing so farther offshore. So the center of the storm will be hundreds of miles farther away from California when it's at its peak. And additionally, instead of strengthening rapidly as it approaches the coast, this one will probably strengthen first offshore and then start to weaken a bit as it moves towards the coast, at least in terms of its minimum central pressure. And so that will probably tamp down the wind-related impacts. There will be some strong gusty winds, but I don't think we're going to see any of those 90 to 100 mile an hour gusts that caused so many problems last time. I think we're going to see gusts more in the sort of 30 to 45 mile an hour range in most spots. maybe somewhat higher than that in the hills and along the coast. But I would expect that most places will see wind gusts that are probably at least 10 or 20 miles an hour lower than with the last storm, if not considerably lower than that. So that it looks like a windy storm, but not an exceptionally windy storm. But the rain might actually be a bigger issue with this one, because it does look like this will be a fairly slow-moving system. So as you sort of watch how this evolves into Monday, it's still just kind of sitting there, and it is weakening significantly in terms of the central pressure filling, but it does continue to send that rain band fairly slowly and potentially stalling it out somewhere along the central coast. Right now it looks like it's going to happen significantly to the north and west of where this happened with the last event, so not over LA County, but maybe instead from somewhere between Monterey and Santa Barbara County. So as I mentioned, the more central coast than Southern California. But the Bay Area, San Francisco Bay Area, and the Central Sierra could be under the gun for a good 24 to 48 hour period. This doesn't look quite as dynamically strong nor as moist as the last event either, so the stalling may be somewhat less of an issue. But again, there is always some concern that when you do get stalling, that if you get those embedded heavy rain bands that stay over the same spot for a long period of time, that even a relatively modest storm by other means can produce significant flooding potentially, especially when the conditions are already mostly saturated, as they are right now. So that is one real consideration here. And I'm just toggling back and forth in time, and you can see that there will be these multiple frontal waves as the storm this rain band and this relatively modest but still persistent atmospheric river-like feature potentially stalls out somewhere along the central coast. Now we're heading into Tuesday morning, and it's still there. And we're still getting cold core showers and isolated thunderstorms in Northern California. And here we are into Wednesday morning, and it's still raining across Southern California. Not as intensely, again, as this last storm, before things finally clear out later on Wednesday. But that's a fairly prolonged rain event in some parts of California. And then there is this other system that might try and get close to the coast later in the week, but then actually might sort of miss California to the west. And as you can see, and I'm going to switch to the ensemble view, zoom out a little bit, give the bigger picture. Here I will go with the European model ensemble, since, why not? Here's what we're seeing right now. This is as of this morning, and you can see here is that strong Pacific jet streak and extension, and you're going to see it extend eastward toward California as we go into the weekend, and there we go. This is Saturday evening into Sunday. So here's Sunday, and here is that low pressure system that, again, just like last time, is developing in this jet sort of this exit region, left exit region. This is the streak, and then this is the left region, and this is the exit region. That's a favorable location for strengthening. However, this low pressure system won't quite be in as favorable of a position as the last system. So look at this low. It's actually sort of north of the jet streak. The system we saw last week that strengthened so rapidly was sort of embedded directly within it, so right near the California coast as it came. So this one will stay just to the north and probably won't have the same opportunity to explosively deepen close to the coast. There is a slight chance that that is wrong, and that this will end up deepening more rapidly and closer to the coast, in which case impacts would be greater. But right now, it doesn't look like a tremendously significant wind event or extremely low pressure system. Nonetheless, that is a pretty favorable look in the ensemble average for a significant storm across most of California Sunday into Monday, as that strong jet streak aligns itself once again over Southern California. That's going to be really effective at squeezing out that precipitation in that relatively modest atmospheric river across Central and Southern California and the transverse ranges, potentially with some embedded convective band showers and thunderstorms once again. And that's always the wild card that could result in more significant flooding along some particular axis that's difficult to pinpoint right now. But as we go later through the week, we see that jet streak goes away, that jet extension does start to fade. This is going toward the end of February, and is no longer zonally extended across the full Pacific. So what we're left with at that point is a strong subtropical jet streak extending over central Mexico into the southeastern U.S. But notice this is mostly south of California. This is a very El Nino-like signature. El Nino is not dead yet, that's for sure, and this is a classic signature out there. But the jet signature makes it a little bit difficult to see what's going on here. But if I bring up the 500 millibar pattern here, this is going toward the end of February and early March. What may end up happening here is instead of this highly zonal, strong Pacific jet pattern, we start to see a mid-Pacific ridge. Now, this does start to prevent those really strong trans-Pacific jet streaks that bring really consistent systems to California, but it's also not necessarily a dry pattern for California. In fact, this could potentially be good news late in February and early into March if this really happens, because this would be a colder pattern for California and a somewhat active pattern. So lesser risk of major rain events and flood events or big wind events, but an increased likelihood of colder storms that would be good snowpack builders. And if we look at the surface temperatures we start to see, we see that with these initial storms, we're probably going to be warmer than average in California. So these will not be good snowpack accumulators for the most part. There just isn't enough cold air. This is going towards late February. But if the pattern continues to be active with that more mid-Pacific ridge pattern, things might cool down later in February into March, and that might be a better snow accumulation pattern. That was the European model, but you can kind of see the same general progression is true for the American ensemble as well, to a slightly lesser extent. So we'll see how that pans out. But overall, right now, if we look at the western U.S. and we look at the European precipitation accumulations, here are the kinds of numbers that we might be looking at. This goes out through about next Thursday, which completes the storm cycle. And again, these are quite respectable amounts, particularly in the northern third of the state and in the Sacramento Valley. These are quite heavy values in the Sacramento Valley. I know some growers don't necessarily want another multi-inch rain event right now. That looks like that is what you're going to get over the next six days. But on the other hand, although this will probably be enough to result in some flooding, I don't think it's enough to result in big-time flooding or seriously concerning widespread flooding. It just isn't enough, because the ensemble average in almost everywhere is under 5 to 6 inches over a 5 to 6 day period. And in February in Northern California, that's wet, but it's not earth-shattering. We do, as I mentioned, but probably see elevated impacts by 1 notch because everything is already wet in most places, so there will be some flooding from this. But unless there is a stall, which is at least there's maybe a 20% chance of a stall that results in a higher impact flood event, but right now there's probably a good 70 or 80% chance that most of the flooding will be minor to locally moderate, not something that's unmanageable. There are some smaller rivers in Northern California that may reach flood stage at some point. At this point in the event, probably not major flood stage by any means, but they may get up there. And that's something to be aware of. Probably more likely to see again another round of stream and small stream and creek flooding in some spots from the Bay Area down into Monterey County and along the Central Coast, and maybe also again in the Central Valley. Some places, I know Yolo County and Sacramento County did see some significant creek flooding during the last event, and that does actually look like a likely candidate to see it again during this round with all of this water coming in on already saturated soils. And just one more thing to look at here in terms of, actually the second to last thing, penultimate thing, and then you'll see my camera come back, is this this view from the Scripps down in San Diego. And let me see if this will enlarge. It's the same size if I do that, so I'll just keep it on the screen as it is. This is showing the atmospheric river potential for a point right near San Francisco over the next week or so. And what you can see really, I wouldn't pay too much attention to the squiggles. What you see is here's the first storm. Things peak sort of at a weak to maybe moderate atmospheric river briefly, so not a big deal storm, but a nice soaking in many spaces. The second event looks bigger, but both in terms of being more prolonged and peaking at a more intense level from maybe a moderate to perhaps briefly a strong atmospheric river. Many members stay in the more moderate atmospheric river category, but they do agree though this will be, you can kind of see this as a broader peak here, so this will last longer. And there are some members, especially with the WRF, so the higher resolution modeling, that see more moderate to strong AR conditions over a longer period. So this is partly because the finer resolution model is able to resolve smaller scale features, so it's always going to have somewhat higher peaks than the global models, but I think it's also because it's better able to resolve some of the frontal waves and potentially a bit of a stall. So again, just as a representative point, there are no members up in the strong to extreme or exceptional category. So that's the good news, is in these really sort of dangerous category up here, there's essentially nothing there for the whole duration. But there are some members that get up into the moderate to strong category, and more significantly, this may be a more persistent event. So, this will be a significant rain event with probably some flooding in parts of Northern California. And then if we go south a bit, let's choose a point. Let's go a little bit further south. This is maybe right around Point Conception. So again, what you see is here there aren't even really any members up in the strong category. They're mostly in the weak to moderate. However, you ramp the impacts up a notch because this will be a fairly, especially event number 2 will be more persistent, so there's a long tail here, and the soils are already saturated, and there may be some embedded convective elements. So this is another case where the atmospheric river scale probably doesn't tell the full story in terms of potential impacts in Southern California. And so just last thing I wanted to show, to be representative, some of you are becoming familiar with these ensemble plume precipitation accumulation plots. Again, each of these horizontal lines represents a single member from the same model, which is run 50 different times for slightly different sets of initial conditions. So this represents the range of plausible outcomes across the full distribution, again, for the European model. This plot is for a point near Los Angeles, so it's supposed to be somewhat representative of lowland Southern California. And the ensemble mean is the very bottom line, suggesting that LA will probably see around 2 to 3 inches of rain from the storm sequence, which is, again, in LA is a significant rainfall event, given that it's a city that often sees less than 15 inches of rain in a year, but it's not an overwhelming one, and it pales in comparison to what we saw last week. So this will be more of a localized flooding and bad freeway traffic kind of situation than a significant flood event in LA in all likelihood. There's a couple of outlying members, so you can see that most of these are under 3 to 4 inches. There are a couple where you see here's a 5 inch accumulation, a 5.7, a 5.5, a 6.8. Those would be more significant flood events, but those are in the significant minority. There's maybe 5 out of 50 members, so maybe there's about a 10% chance of a more significant flood event there. There's also a chance that this event is really a non-issue at all, because there are a few members that are under 1.5 inches. Here's a 1, here's a 0.7. So you can see this same plot, by the way, was the one that was showing some values between 15 and 20 inches for the same period during the last storm. There are no members even half that in this case. And so that is, the good news is I don't think this is going to be a major flood event for LA, San Diego, Orange counties. It'll be another nice soaking rain, probably bringing all locations that aren't already above their seasonal average to well above seasonal averages, and clinching that El Nino seasonal prediction of a tilt towards wetter than average winter. Well, I think by the end of this event, we will be there throughout Southern California and probably the Central Coast as well, without having another major flood event. Again, there's a 10% chance that changes and this becomes a higher impact flood event, but that also means there's a 90% chance that it probably won't. And even then, the very wettest members right now are dramatically less wet, maybe by a factor of 2 or more than during the last event. Here's a point up by San Francisco. It's exactly the same plot, the same model. It is, of course, wetter. San Francisco stands a better likelihood of seeing 3 or 4 inches of rain, although, of course, San Francisco is on average a wetter city than Los Angeles, so in terms of the relative anomalousness, it's probably similar. Here, there is a slightly wider range in outcomes. You can see here there's one member that only has 1 inch of rain. I think that's unlikely to happen. That's pretty low. And there's the wettest member is up around 7.8 inches, which again would connote a more significant Bay Area flood event. But notice there's really only 2 members, I believe, this one and this one, above 7 inches in San Francisco. Most of them are clustered between about 3 and 5 inches for San Francisco, so pretty close to the mean of 3 to 4 inches. And so I think that's a pretty solid estimate. Again, often you can double the numbers in the mountains, so if San Francisco sees 3 to 4 inches I'd expect 6 to 8 inches in some of the coastal hills, which is probably where most of the flooding would occur from this event. So that's it's a hefty, but again, not catastrophic rain amount for the coastal mountains in the Bay Area. So a significant rain event on already saturated soils will usually lead to some flood risk, as will be the case here, but it doesn't look earth-shattering. And notice that there are no members up above 7 or 8 inches for San Francisco. So this is not a situation where there appears to be a very high ceiling. It appears that the ceiling is somewhat higher than the mean, but not dramatically so, unless something changed. So I think that's the good news here. And I guess what I can do is I can pull up the potential wind gusts from the same model. And so this gives you a sense of the potential of the range of potential wind gusts. Most of these are suggesting that San Francisco could see some wind gusts up to around 35 to 40 miles an hour. So again, windy, but not super damaging. But if you look, there are, a handful of members that have gusts more up into the 50 or 60 mile an hour range, which again would still be lower than the 70 plus mile an hour winds that San Francisco saw during the last round. But in general, I would say most of the Bay Area will probably see gusts 35, 45 mile an hour kind of range or lower. Same with the Central Valley. So I don't think that the power outages, the tree damage, that kind of stuff will be nearly as significant as the last round. This looks just a little more ordinary. All right, so I think that's all I wanted to show in terms of data on this one. And I'm going to bring my face back. You'll see me again. Oh, actually, there was one more thing. I'm glad I remembered before switching over. There is some chatter about the potential for some stronger thunderstorms in parts of California on Monday. And I actually think that is justified, because here is... so obviously this map is calibrated, by the way, for people who look at severe weather in the Midwest, where Cape convective available potential energy is often in the thousands. The units are in joules per kilogram, essentially the amount of potential energy in the atmosphere, really, or more directly a metric of potential instability. But anyway, the scale is set so that in California, usually everything just appears on the dark end. There's nothing there. But look at what happens when we get closer to Monday. So this is Monday morning. Here is Monday morning and Monday afternoon. So let's freeze frame it here. This is late morning on Monday. And even with the scale set to Midwest values, there actually is something to talk about for especially the Central Valley. And let me pull up a sounding. Haven't done this in a while on this tool. So this is what's known as a skew-T plot, which is actually pretty difficult to interpret without some training. But the main thing I wanted to pull up here is this, which is the surface-based Cape, around 900 joules per kilogram. And this is in a global model, so often the global models will underestimate what the high-resolution local models will end up saying. So there may end up being pockets of convective available potential energy in the Central Valley on Monday, late morning into afternoon, above 1,000 joules per kilogram. That is pretty high by California standards, and often when we get values that high, we do tend to see at least some isolated severe thunderstorms. So I would not be surprised to see a couple of supercells, at least in the Central Valley on Monday. And there could be more than a couple. This is one of these slightly more notable early signals. Sometimes there's not a lot of notice for these sort of Central Valley thunderstorm outbreaks, but with this one, there are some early signals it could be a rather significant one on Monday. There should also be some potential for thunderstorms along coastal areas too, with the potential once again for locally torrential downpours, or even a local tornadic spin-up or two along the coast especially, but in this case maybe also somewhere in the Central Valley, especially from the Sacramento area northward. So this is something to keep an eye on for Monday in terms of that potential for locally severe thunderstorms, some larger hail, and maybe even a local tornado. Traditional season is from February through March or April in Northern California, to the extent that there is a tornado season in the Central Valley, which there is to a limited extent. So this would fit with that, and this will be a relatively mild storm, and this will be on the back end of the storm when some cold air aloft moves in. So that's part of the reason for the instability. There will be a little bit of wind shear and surface relative helicity, especially along local boundaries, that could potentially result in a spin up or two. So that could get interesting on Monday. I may try and have a brief live session then if something interesting is going on. This may also be around the peak of the storm in terms of rain or shortly thereafter. So Monday could be an interesting weather day in Northern California, not necessarily because of a very severe widespread storm, but because of some flood risk and the potential for at least some isolated severe thunderstorms, which is a bit unusual for a storm like this. All right, now I really am done with this shared screen, so you're going to see my face again. And I'm going to take a look at the questions. All right, here, so let's see what we've got going. So the first, I got a question from Ezra Romero. What does all of this precipitation and snow mean for California's water supply needs and thoughts? Well, you know, we're not in a meaningful drought this year, that's for sure. And even if snowpack isn't great, even if we end the season with, you know, between 50 and 70% of average SWE, snow water equivalent this year, we'll be doing okay because we have a lot of carryover from very good snow year and very wet year last year, and the fact that this year isn't actually very dry. In fact, it is wetter than average in most of California. It's just that the Sierra has sort of been bypassed by some of these storms, and some of the precipitation that's fallen up there has been rain rather than snow. But it's not necessarily super dry across most of the Sierra, and in particular, from a reservoir perspective, there is carryover from last year. You know, we do know that in a warming climate that it's going to be harder and harder for our reservoirs to capture that snowmelt as they were designed to do, as there is less of it and it occurs earlier in the season, more aligned with big winter storms. And we've definitely seen that this year. But this is a year that's wet enough, following on the heels of another wet enough year, that I'm not super concerned about water supply this year in California. There's not really a foreseeable likelihood of major shortages or real concerns there. Now, the question about wildfire season might be a bit different because a low snow year does mean that things are going to dry out sooner in the mountains than they would otherwise, and that might mean that it's off to an earlier start, depending on how the rest of the season goes up there. It's a little bit early to talk about that. Usually we use sort of April 1st snowpack as an early indicator of that. But also, it really is going to depend on fire season this coming year more broadly on how hot it gets. Because it's been a wet year. In particular, it will have ended up being really wet in Southern California. But here's the paradox. In parts of Southern California and in more brushy and grassy areas around the state, it is in fact the wet years that are often the big fire years historically because there is so much additional growth of that vegetation. So in the dense forests, usually it's the dry years that are the worst fire years. In sparser vegetated regimes, including the chaparral environment in Southern California, it's often the wet years that are followed by hot summers and dry falls that are the biggest fire years because there's a lot of extra growth during the wet period, and then all of that inevitably dries out and becomes potential increased fuel for the fires later on. Last year we didn't see that, partly because it was so wet and so cool all the way through early summer, and then we short-circuited fire season in Southern California with Tropical Storm Hillary related heavy rainfall in August, so everything was wet starting in August and never really dried out in September and October, so we didn't get that big fire pulse in the autumn last year. But, you know, if we're not saved by the bell in the same sense this year, that could result in a more active fire season this year, especially if this summer is particularly hot. And right now, seasonal predictions suggest that it very well could be quite warmer than average in spring and summer, which would be different than last year and could lead to a different wildfire outcome. Keep in mind, in 2017, in autumn 2017, parts of Northern California had seen their wettest winter on record and then went on to see catastrophic fires that autumn because it was just so ridiculously record-breakingly hot and dry from summer into early autumn that when the autumn winds came and there was no early season rain that year, that there was both additional vegetation that grew because it was so wet and cool earlier in the year, but then the record heat later dried everything out to record dryness levels, and then that was what really fueled some of the intensity of those fires. So we could potentially be setting out for a similar situation this year. There's been a lot of vegetation growth and regrowth, even in some of the wildfire burn areas from recent years. I think there's, a lot of the 2020, the huge areas burned during that incredible fire season have filled in with grass and brush, and most of them probably could sustain continuous fire at this point. Maybe not the same intensity they did in 2020 because the fuel is maybe not quite as dense, but in terms of providing a continuous fuel bed, especially during a wind event, I think we're there again. So some of those fire burn areas from the 2010s, that terrible decade of California fire, have started to fill in. We've had a couple of mild fire years and wet conditions that have allowed that to happen. So the next time it dries out and warms up a lot, and it very well could be this summer into the autumn, then we may see a transition back toward a more active wildfire conditions. But we'll know more about that in April and May once we have a better sense of what the Sierra snowpack looks like and how much water we got between now and the end of the season. So a long answer to a couple of questions that weren't even asked. How's that for a bonus round? All right, let's see here. A question from Marty about how scientists link precipitation data to groundwater recharge in real time, not geologic time. That's a good question. I'm not a geologist nor a hydrologist, so I don't have the direct answer, except to say that until somewhat recently, we weren't really actively monitoring groundwater in most parts of California. Like, we didn't have any real-time read on this. And now we have some sensors installed to detect this as part of the legislation in the past decade surrounding groundwater sustainability in California, although there's still a lot we don't know. Some of this comes from remote sensing. So we either fly aircraft with downward-looking sensors to get a sense of this, or even there's a pair of gravity monitoring satellites in space known as the GRACE mission, GRACE, and it is literally a pair of satellites that orbits the Earth, and as it passes over different regions, the distance between the satellites changes very slightly as the Earth's gravitational field varies very slightly from place to place. And so because the Earth's gravitational field varies slightly and these satellites are at slightly different locations, the gravitational pull on them varies a little bit and is differential between one and the other. And we can measure changes in groundwater based on the gravitational anomaly field, these finely tuned satellites, as they become slightly closer or slightly farther away from each other over time. So that's kind of a cool use of that satellite technology to figure out where groundwater has increased or decreased. We can only tell it in relative terms, so we only know whether it's increased or decreased relative to the baseline since that satellite has been up there. So we don't necessarily know what it looks like relative to 1980 or 1950 or 1250 AD because we didn't have satellites up there, but we do know from year to year the main reason why these gravitational anomalies occur over land is due to variations in the water table and the amount of groundwater that's there, and it can be significant from year to year. There are other things that can happen, of course. Can be sea level changes, but usually that's not dramatic from year to year. There can be major geologic events, I suppose, too. But again, there hasn't been such a major geologic event on a large scale in California. So remote sensing is the main way to do it, although we do have some in situ sensors. I don't really know how quickly we can measure that. GRACE measures this usually on seasonal scales. So that's definitely shorter than geologic time, but it's faster than meteorological time, if you will. I don't know if the in situ sensors in the ground themselves, measuring the actual level of groundwater, are a little more responsive. So that would probably be a better question for a hydrologist. Question from Warren. It looks like the second storm Sunday, Monday is falling apart a bit, which brings down the flood threat for Southern California. I don't think it's falling apart. In fact, I think it's pretty much consistent with the prediction all along to be a much less significant storm for Southern California and in particular for Los Angeles County. So there will be flood risk, but it will not be the kind of major widespread flood risk we saw with the last one. Again, as I mentioned, there's about a 10% chance that it ends up being a significantly longer or more intense thaw, in which case the flood impacts would be greatly increased. But the upper end, the ceiling on this one is, I think, a lot lower than the last one. So I don't think this one's going to be as disruptive or as problematic as the last one, at least in Southern California. Now, the flood-related impacts in the Bay Area could actually be higher from this event because it is focused more on Northern California. There is still uncertainty. It depends, again, if that system bombs out a little bit closer to the coast or stalls longer than expected, then the impacts could be higher than expected. But right now, most likely outcome is some modest flood risk in Northern California, extending down the Central Coast and maybe into Santa Barbara, Ventura counties, but probably not much farther east than that, unless something weird happens. And there's about a 1 in 10 chance of something weird happening. Yeah, a couple of folks have noted that much of the San Francisco Bay Area is under a flood watch, which makes sense. There definitely could be some flooding this weekend. Again, I don't expect it to be terrible, widespread flooding, but, flooding is flooding. So I think it is important to differentiate between the really big events that are kind of scary and the ones that are more, a little more ho-hum, if you will. But always take flooding seriously, even if it doesn't look like it's going to be a particularly severe or widespread event. And again, with these kinds of slow-moving, stalled systems, we've seen this before, where sometimes there is some section of coast, 50 to 100 miles wide, that gets stuck under a persistent atmospheric river or convective rain band and sees significantly more rainfall and worse flooding than would otherwise be foreseeable at this stage. And this is the kind of pattern where that could happen. So there might be some section of coast that sees higher flood impacts than expected. Yeah, so I'm seeing the intermittent screen freezing issues too. In my case, it's not too bad right now, but I am at this point trying to be aggressively pursuing my internet service provider now that they are actually responding to my requests. So I'm actually doing a quick speed test right now just to see if it's the actual internet speed or whether it is my computer hardware, software, some combo of that. And it looks like in this case, I don't necessarily think I can blame the ISP because it looks like, so perhaps this is just me running with too many tabs, so I'll have to remember not to do that next time. Apologies for that, but it seems like the internet connection is probably good enough right now. So this one may be on me, but we'll see next time. Well actually, it's the moment I said that, here goes the connection again. Alright, well, it looks like I'm going to be spending the rest of the day on the phone with the ISP again, so Xfinity, if you're listening, prepare for a phone call. Alright, so, but it's not so bad I have to stop. I forgive the transient video interruptions. Let's see here. A few more questions coming in. Question about whether in mid-March we'll be past most of the major rainstorms in Northern California by then. Probably not. Mid-March is still quite a wet time of year up in Northern California, and in some years even into April. So you might get lucky with a dry window, but I definitely wouldn't count on a dry window in mid-March. That is still definitely the rainy season most years in Northern California. Is there a risk for higher than normal waves and tides with this system? Ivan asks. Yes, generally speaking, yes, but not to the degree we've seen with other recent storms, probably. So, again, this will be a familiar flavor of things we've seen this winter, but probably in most cases less extreme than we've seen with other events. let's see. So there's a question about and I've mentioned this before, the Tonga volcanic eruption from now 2 years ago and its effects on the atmosphere and storms. There is ongoing science and ongoing uncertainty with this, but right now it looks like it probably had a smaller effect than some had initially hypothesized, to the extent that it may not have a noticeable effect at this point, despite the magnitude of the eruption and the stratospheric water vapor injection. Remains to be seen. That's sort of ongoing research, but right now it's not looking like it's a major causative factor in a lot of the things that we've seen over the past year or so. All right, and then the last thing I did want to talk about in this session briefly was the hubbub over the AMOC, the Atlantic Meridional Overturning Circulation, which is a global ocean current system, as you might expect, in the Atlantic Ocean, but it does extend both from the surface of the Atlantic Ocean all the way to essentially to the bottom of the Atlantic Ocean, all the way from the subpolar or the polar North Atlantic all the way down to the polar South Atlantic. So that's a huge extent of the global oceans, essentially from the Antarctic seas all the way to the ocean off of Greenland. And it's hugely consequential in keeping Europe warmer than it would be otherwise, and along with a whole host of other key features of the climate that would not exist were it not for this workhorse of a heat energy redistribution system built into the Earth system. And this is a key means by which energy would otherwise accumulate in the tropics, dissipates, is transported towards the poles, where it is easier to dissipate it through radiation to space. And so it is part of the Earth's heat engine. And there has long been an understanding that at certain points in the Earth's history that this redistribution system has shut down and that it is subject to some instabilities. And we know from the paleoclimate record that at times when there were vast continental ice sheets in the northern hemisphere, we're talking about continental land ice that extended down to modern day Midwest or Chicago. So essentially the era when Canada was completely covered by ice, the whole country, and much of northern Europe. Much larger ice sheets than we currently have right now, of course. That the North Atlantic current was subject when there would be large meltwater pulses, because of course land ice is fresh water, it's not salt water. And so when you melt a bunch of it quickly and inject it into the ocean, it can change the buoyancy profile, the salinity profile, because you're injecting a bunch of cold, clean, not salty water into a relatively warmer, much saltier body of water. And so you can disrupt these vertical overturning currents by dramatically perturbing the density, because overturning suggests there is a vertical component to this current, and that is the key piece of it, which you can disrupt if you inject a bunch of cold, fresh water at the surface and disrupt and displace the saltier, warmer water that was there before. And so in these periods where there were these vast continental ice sheets, you could get pretty rapid injections of fresh water when they would melt in pulses, when there'd be these outburst floods of fresh water from the continents that would essentially shut down, at least have the potential to shut down this current, and did in fact, according to most paleoclimate records, did shut down this current rather suddenly. There's been some ongoing debate as to how quickly this happened, and there's now evidence that this may have occurred over the course of just a couple of decades. Again, we're talking about thousands of years ago, but the idea is that it is subject, there really is a tipping point likely in the system where you can add enough fresh water to tip the system over quickly on this time scale of less than a human lifetime, which in geologic time scales is extremely fast. And so the system is at least somewhat unstable. We don't know where that point of instability is, and this has been the subject of ongoing debate, genuine scientific debate. We don't know exactly where this tipping point is, and we don't know exactly how close we might be to it now. Now, of course, we don't have nearly as much continental ice to melt and to form these gigantic freshwater floods into the North Atlantic that we did thousands of years ago, and we have these vast continental ice sheets. So that works somewhat in our favor. But on the other hand, some recent evidence suggests that the system may be even more sensitive to smaller perturbations than we previously thought, and that the coupled climate models that we had used for decades to make those assessments might be underestimating the instability of the Atlantic meridional overturning circulation. There's some recent research that further strengthened that claim and then went on to make some statistical observations that the observed behavior of the current system itself might be indicative of what's known as a critical slowing down, or essentially a potential early warning that it is approaching that region of instability that would result in a rapid slowdown or shutdown. But this is controversial. This is not widely accepted necessarily. On the one hand, some of the folks who believe this is potentially a real risk are legitimate domain experts. These are folks who study the current system and are physical oceanographers and dynamical theorists, and it's a little bit concerning when the domain experts in this field are the ones, at least some of them, who are raising the alarm. But on the other hand, there is countervailing evidence that the observations used in these early warning analyses are subjects to artifacts in the methodology, and we don't have, part of the problem is no one's willing to pay for a monitoring system. So we have a discontinuous record that is interrupted, and we don't have a good enough long-term record. In fact, we have better data from a few decades ago than we have from right now. So we don't know exactly what the system is doing in this moment where we think that it might actually be more susceptible to tipping than we used to think, which is kind of an alarming thought, that we would have even less capacity for early warning now than we might have, in the past. Hopefully that changes, but the point is, some of these headlines suggesting that the AMOC is imminently hitting for a tipping point in the next decade or so are just wrong. There really isn't any scientific evidence that suggests that the system is imminently likely to collapse. However, that probably shouldn't be all that reassuring, because there are experts, and I've been speaking with some of them recently, just in the past week or two, in the wake of these media headlines, that there is probably, in their view, at least a 10% chance that it does tip this century, and that the tipping point could potentially be as soon as a couple decades in the future. So think of it this way, and this is the way I keep framing it. 10% is a pretty small likelihood if you're worried about a chance of showers. I probably won't bring an umbrella for a 10% chance of showers, but that's mainly because the consequence, if you're wrong, is very low. You get wet. It's not the end of the world. 10% chance of this happening, though, is a bit of a different can of worms, so to speak. And so I think we need to be approaching a 10% chance of something like this quite differently than we would with a 10% chance of showers in the forecast. And there is a lot of uncertainty about whether the assumptions in some of these underlying analyses are correct, or whether there are artifacts in the observational methodology. But what is clear, I think, at this point, and there is modeling evidence for this now, that the system, there's a pretty good chance that it is at least physically susceptible to sudden rapid tipping point change. And there is at least a slight possibility that we are closer to it than we used to think, and that we could reach that point this century. And although it's not likely, it probably wouldn't happen for decades or longer, even if we are on that path, I don't think we should be especially reassured by the fact that there is, quote, only a 10% chance of the AMOC tipping in the view of some of the world experts on the AMOC, because it would be a big effing deal if it did. And so I think that's the right framing for this, is that there's a number of these things right now. There's another study about the Amazon and tipping points that came out this past week. None of these are imminently certain or likely. So the framing that they are is inaccurate. However, the fact that the domain experts who really study the Amazon, or who study the AMOC, think there is at least a 5, 10, 15% chance that this happens within the century and potentially within the next few decades. Again, do we really want to bank on that 90% chance that each of these things won't happen? The likelihood that each of these different Earth system tipping points won't happen, by the way, is only partially correlated. So we're kind of rolling the dice with each one separately. They're somewhat related to each other, but generally speaking, if there are 8, 9, 10 Earth system tipping points, and they each have a quote-unquote only a 5 or 10% chance of happening, well, what are the odds, that one of them tips, at least, when you do roll that dice? When there are 9, 10 rolls of the dice that are somewhat independent from each other. Then the odds aren't so low at all that at least one of them gets to a point where we don't want it to be. So that's probably a topic for a longer conversation than I have time for today, but it is food for thought, and I think it offers some context for all these headlines surrounding the AMOC, in the sense that it is not, there's no evidence of an imminent day after tomorrow type scenario, which, by the way, is physically impossible even in the worst case. But I don't think this is something that we can totally dismiss, because it's an example of something where even though the odds are relatively low, they're not vanishingly low, and the consequences, should it actually occur, are so high that we really should be seriously considering the possibility, even if it is only a 5 or 10% chance this century. So anyway, that's my view, and it looks like the stream quality is getting even worse, so I need to go bug Comcast. So with that, thank you. I'm going to try and have a new blog post later today, assuming Comcast doesn't eat up all of my time. But thanks for joining, everyone. And again, this weekend storm in California looks significant, not dramatically terrible. But one of the notable things will be the flood risk from the Central Coast up into the Bay Area looks elevated for sure, and the potential for some severe thunderstorms in the Sacramento Valley on Monday. That looks like it could be an interesting auxiliary thing on the back end. So anyway, check out the blog post later today. I'm on social media as usual, and then I got to deal with this internet stuff. So thanks again, and talk to you next time.